Hello students, today we are going to solve a question from JEST 2022. It's a part of optics, thin film interference. The question number is A, part number 18. And the question is given, you have a thin film having refractive index mu equals to 1.4. And this thin film is basically surrounded by air. So there's air outside of its surrounding. And also there's a white light incidence normally on this thin film, and as a consequence of interference this thin film is appeared to be blue, having wavelength lambda equals to 400 nanometer. Okay, so I have to calculate the minimum thickness of thin film. Minimum thickness of the thin film that we have to calculate. Okay. So as you know, there is a normal incidence of light. It means angle of incident equals to angle of refraction, and that will be 0. And for constructive thin film interference, we'll have a condition like twice mu t, that is equals to n plus half lambda, where n can take values like 0, 1 and 2, so on. Okay, so that thickness is depends upon this integer, and that can take values like 0, 1, 2, 3 and so on. And of course that thickness will be minimum when n is having minimum value, and that is 0. Okay, so I'll get minimum thickness when n equals to 0. Now if I substitute that n equals to 0, I'll get mu t minimum, and that will be lambda by 2. It means t minimum or minimum thickness of the thin film, that will be lambda by 4 mu. Okay, and lambda is given, that is 400 nanometer, divided by 4 into mu is given, that is 1.4. So if you calculate it, you will get around 71 nanometer, but according to that given option it was close to 70 nanometer. 70 nanometer will be the correct option for that question. Okay, thank you.